Hey guys, good morning. Let's move along here and take a look at a couple pictures here first. Take a wild guess as to what the theme may be here. Yeah, it's all about stairs. Slopes of lines make me think about stairs. I wonder why that is. Maybe it's that nature right here that we look at stairs and we picture, two things here. Rise, over, run, Kind of, maybe that's what I'm thinking of. Lots of different slopes there, right? Kind of goes up, and across. Slope! Look at that one. Wouldn't you like to have some stairways like that, where you have stairs on one side and a slide on the other? That'd be sweet. Very steep sloped on those stairs. That's interesting. Alright, so here's what we're doing today. We're going to write some equations from graphs and we're going to calculate slope. So just as a little bit of a warm-up here, and we've done this a couple times. Is the slope of this line positive, negative, or 0? Yep, positive. Why? Because it's going up and to the right. Rise over run. Up and to the right. Up and to the right. What about the slope there? Yep, negative. What about there? 0. Just like that, positive. Alright, so what we're after today is if I give you a line, what I'd like you guys to be able to do is not find x and y intercepts like you did before, but what I'd like you guys to be able to do is write the equation for the line in slope-intercept form. So when you're writing the equation for a line in slope-intercept form, remember there's a reason why we call that thing slope-intercept, right? Remember, here is the slope, and right here is the y-intercept. And it's only the y-intercept, it's never the x-intercept. So looking at these lines here, you need to substitute two numbers in there, one for the slope and one for the y-intercept. So when you do these, try and find some key points on those lines. We can go back one step here. Notice this line crosses the grid lines at some nice clean points right there, right? Right there and right there. So then we can get some nice key points there. And then we can pinpoint that pattern there, right? Look at those stairs. What are those stairs doing? They're traveling down 2 as they go to the right 1. Which means that our slope here with rise over run has got to be negative 2. Our y-intercept, which was this value right here in blue, it crosses the y-axis right there at 1. A positive 1, right? So we can write it just like that. There's our line in slope-intercept form. Pretty simple. So looking at these examples here, notice they already put the key points in there for you. So when it comes to slope-intercept form, some non-negotiable stuff, ladies and gentlemen, the y and the x is always going to be there. What you need to worry about is finding the slope and finding the y-intercept. The slope, if we're calculating that, with these key points right here, notice how far up do we go before we start traveling to the right to get to the next point. How far up is that? Yeah, let's see, 1, 2, 3, 4. No, 3, just 3. Yeah, 4, 5, 6. So up 3. And then, how far to the right does it go? 1, 2, 3, 4. To get to that next point. And if slope is rise over run, then we have 3/4 for our slope. Now what about the y-intercept? Y-intercept, that's where the graph crosses the y-axis. So it's that spot right there. Isn't that at a 3? So a positive 3. So there we go. Easy peasy. Let's look at another example. How about this one? Sometimes you might run across examples where they don't put the points on there for you. So it's important to find those key points. So some key points here. Obviously there's your y-intercept right there, and as we travel, hey, look at that. Travel, hey. Travel, hey. Alright. So what was the slope? What was our pattern? Up, stairs, stairs, stairs. Look at that pattern. We are going up 2 as we travel to the right 1. Up 2 to the right 1. Up 2 to the right 1. So y equals 2x, and then our y-intercept was that point right there. Count it out, count it out, count it out. Down 1, 2, 3, 4. So down 4. We're going to write that as minus 4 to indicate that we were down there 4. Simple, right? How about this line? Remember that earlier warm-up we had here? What do we know about the slope because it goes down and to the right? We know that when we write our slope number, it had better be a negative number of some kind. Well, negative what? There's our y-intercept there, key point. I think that one is. Boy, this becomes tough to spot. I don't think that one is. Let's look at this a little bit closer. Yeah, I don't think it crosses right there. How about that right there? I think that's good. Notice the pattern that we had right here. Rise, we went down 2, 1, 2, 3, 4, 5. Let's see if that pattern repeats itself going in the other direction. In other words, can we go up 2 and to the left 5 and land on another key point? Up 1, 2, 1, 2, 3, 4. Hey, I think we got it. So there's some key points right there, right? So if we're going down and then to the right, you're always going to want to make your slope travel to the right. That way, your run is always a positive number. And what was our run here? That was 5 squares, right? And then our rise, we went down 2. So there's our negative 2x. Our y-intercept was right there, which was at a negative 1. Okay, take a look at this. If I gave you a point here and a point there, could you tell me the slope of the line that it creates? Yeah, pretty simple, right? We just know it goes down 1 and to the right 4. So our slope here would be negative 1/4, right? I'm going to call it m, just to be along the same lines as y equals mx plus b. So I'm going to call slope m. Pretty simple, right? How about these 2 points? What's the slope of that line? I like this problem because notice you can count the squares here. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. So slope, rise over run, would give us 1. If you go back here, look at this. Aren't these more key points right there? So notice we could have also found the slope using those. Any combination of 2 points on this one would have given us a slope of 1. Whether it be those 2 points right there, or if we decide to say, hey, look at this one here. Let's do rise over run here, going from this spot to that spot. Notice we would have been up 3 and to the right 3. Slope still would have been 1. I'm going to put a table on the side here and let's do the same thing. What if we had the 2 points and it gave them to you like this? 2, 2. So there's one coordinate. And then a second coordinate right here of 5, 3. Well, you'd have 2, 2 right there. 5, 3 right there. Finding the slope right there. Rise over run. We're going up and then to the right. So our slope here would be 1 over 3. So 1/3. Notice this. Interesting. These ones. Negative 4, 1. 0, 6. What's the slope? Rise over run, right? So rise over run, we went up 5. Looking at this. Positive 4. Looking at that, negative 4 to 0, we went up 4. And oops, forgot to write the slope here. So what's our slope? Rise over run. So we went up 5 and to the right 4. What if it just looked like this? With no graph provided, could you do it? Wasn't it just a matter of looking at this here and saying, hey, I'm traveling from here to here? -2 to 2. Wait a minute, think about a number line. If 0 was here and -2 was here and 2 is there, what's the distance between these two? Oh yeah, it's 4. So we went up 4. And then here, rise, there was a rise, now here's time for a run, going from 3 to -1. Wait a second, 3 to -1, we actually decreased. We went down a total of 4. So rise over run gives us a slope here of what? Oh, this is me, I forgot we had this here. So there's our 4, there's our -4. So rise over run, we get -1, right? What's different about this one? Do you notice all I did is just switched the order? Can we still get away with getting a slope of -1? Going from 2 to -2, notice we decreased by 4 that time. And then going from -1 to 3, we actually increased by 4 there. So that's a run down there. Notice we're also still going to get -1.